So, so I'm Travis McMahon, and I'm giving a presentation on game development with LibGDX. How does this work? Should click right there. Yeah. So I'm Travis McMahon, giving a presentation on LibGDX. I am a hobbyist game developer, kind of. I like to mess around to do different things with games and see what we can prototype and come up with. So what is LibGDX? LibGDX is a cross-platform Java game library that was created by Mario Zechner. He created it because he really hated the Android, developing games on Android with having to go through either the phone or the emulator. And it was like really slow to development. He wanted to have rapid prototyping, mainly on the desktop. So he created this library where he could develop stuff, do his whole development on his desktop, all the testing, all the code, and then port it over to Android with like a single click. The major features of LibGDX is the cross-platform ability. It can go to almost any platform. It goes to Mac, Windows, Linux, iOS, Android, BlackBerry. It can even be compiled down into JavaScript and run in the web browser with just native JavaScript. It has a lot of utilities, mainly for 2D. It has some support for 3D, but it's not major support. It's mostly just gives you access to the OpenGL bindings, and you have to do everything manually. It has audio playback, and it abstracts the input handling, so touch and mouse events are all handled the same. They're like one type of event. There's also keyboard, gyroscope, accelerometer, and a compass if you wanted to use all the fancy stuff on mobile. Has its abstracted all the file system, so you go through the same file structure as you would for any platform, so you don't have to change anything for platform-specific stuff. And it has built-in physics and math utilities. The main feature through it is the community. It's all open source and community-driven. If there's a feature you want, you can probably go on the forum and ask someone to help you implement it into the library. You can build third-party tools for it and get implemented into the app and make the community grow. So as I said before, the major feature was the cross-platform ability of it. All your code is in one code base. You don't have to do anything for the other platforms except for getting the launcher set up and doing the basic configuration like screen size and all that setup. So this is a screenshot of just a sample app I made. On here you can see there's a bunch of projects. There's one for Android. That's where your Android launcher is, and you can set up all your Android properties and do some specific stuff for Android there. You have your core module, which is where all your game code will live. And here it just has the MyGDX game, which is just the basic game listener or application adapter. Then there's the desktop version, which has the desktop launcher, which sets up the display size if you want. And then there's the HTML, which goes to the JavaScript and iOS. Each platform has their own launcher, and each launcher has their own configuration class. The configuration class sets, like I said before, like the screen size, what version of OpenGL you want to use, and you can put more specific stuff in it, like the color depth, some special features you want to use or not use. For it, LibGDX is also all event-based driven. There's no main loop, mainly because Android, there's no main loop. You have to have an I forget what it's called, but you have to have a specific class and just all event-driven. So it's been implemented throughout the whole platform that everything is event-driven and there's no like main loop. So the application lifecycle of a game in LibGDX is there's the application start where it launches from the launcher, gets the configuration, sets up all the stuff in the background. Once that's done, it goes to your game class, calls its create method. That's where you initialize basically everything you want, like load all your images, sounds, set everything up. Then it calls the resize. Resize is called whenever the screen is resized, but it's always called on the first time the application starts. And on Android and iOS, if the screen goes away and comes back, it gets called again. After that, it goes into the main loop, which isn't really a loop. It calls the application it calls the render method in the application, and it just keeps calling this over and over for like a however FPS you set it for. I think it's default for 30 FPS on Android and 60 on desktop. So it calls this 60 times a second, and if an event happens, like if it loses focus, it will call the resume, or it'll call the pause, then resume, regain focus, and keep doing this until the application closes. Once the application closes, pause is always called, so this is a good place to do all your cleanup. Then after that, dispose is called and clears up all the OpenGL contexts and all the memory management that is done automatically, except for a few things. And that's the end of the application. So all applications in LibGDX have to implement an application listener. This is the main one that has all the methods like the create, update, or render, pause, resume. There's 2 classes that are already extended for you. There's the application adapter, which is an abstract class that just basically sets everything up and makes it so you can just create a very simple game that's like one screen. And then there's the game class, which is a more slightly enhanced version of the application adapter. It allows you to create up the game, and then in that game you can have like many different screens. A screen can be considered like a main menu, game screen, or inventory. Anything that's like can be put in its own little sub compartment that can be run as like a separate game. From these, you can call other screens and do a bunch of transitions and have a flow in your game. So LibGDX is mainly meant for 2D. So it has most of its features are primarily to help you with 2D. It has a lot of texture. It has texture class, sprite batching, cameras, texture atlases, bitmaps. It has some nifty little utilities, like has a particle rendering, a 2D particle system. It supports tiled maps from an application called TMX. Well, it's like a GUI where you can draw maps with tiles and have sorry. It also has a 2D scene graph and a UI library. The main features for the main things that you'll always be using will be probably these 6 things. A texture loads an image into the GPU memory, so OpenGL can use it. A texture is just the image information, just the pixels, and you can draw it and do nothing much else without just like put it on the screen. A texture region holds information about a texture, like a specific region, like a rectangle, so you can have one texture and many texture regions and draw different portions of it through, with just one texture. And a texture region is used in a texture atlas, which is also commonly known as a sprite sheet. So you can have a bunch of images on one giant texture. So you can, this optimizes rendering, so you don't have to keep switching textures, and you can just do a bunch of, one batch of vertices to the graphics card. Then there's the sprite, which holds a texture or a texture region. This holds all the information about the image you're drawing, like the color, position, rotation, the geometry, and you use this mostly for the positioning of stuff and actual drawing. Then there's the sprite batch. The sprite batch is like the 2D renderer for LibGDX. You have to use it to draw textures or sprites, unless you go with your own OpenGL implementation. Basically what it does, it collects, you just like start it and then you end it, and everything inside the start and end that you call like sprite.draw, you would pass the texture or image, or I mean the sprite batch, and then it will combine them all into a giant array of vertices and push all of them at once to the GPU, so there's only one push call, and do really fast rendering. But this only works if you have the same image or same texture for all the batches, and that's why the texture atlas and texture regions are really useful. So you don't have to do multiple swapping. And then there's the sprite cache, where if you're drawing lots of the same images, but they don't really change much, you can have the sprite cache to store the vertex data and keep it on the GPU, and you don't have to keep pushing, and it'll just render it on its own. As I mentioned before, there's a 2D scene graph in LibGDX. It's a very simple hierarchy of just actors and children. You can add an actor to the scene graph, and it will handle the updating of its position relative to the parent and the rotation and scale. Each of the actors have their own local coordinate system, so when you're in an actor class that you're creating, you have to do everything's in your local system. You don't have to worry about the parent's rotation or anything. Everything is just on your own. There's a single sprite batch for the whole scene graph, so there's only one. It helps with the efficiency of rendering there. And there's an event system for managing and routing event input to the correct actors. So if you click on the screen and there's a bunch of actors that you can click on, it will go to all of them until it gets to the right one. And then there's an action system for manipulating actors, like changing who's their parent, if they can do transitions and transformations. There's the 3D API for LibGDX is still in development. They're still creating a lot of helper classes, just like they did for the 2D part, where they have the sprite batch and all this fancy stuff. But basically right now they just have a bunch of Java classes for all the OpenGL stuff. All the rendering done in LibGDX is done with OpenGL ES 2.0. And all these features can also be used in 2D if you don't want to use anything specific that LibGDX has. Like the sprite batcher has a shader class in it, and you can change that out with your own shader so you can do fancy graphics in 2D instead of just having to go straight to 3D. But basically it has a vertex array and vertex buffer objects, which help you with managing, pushing your vertices and stuff, vertices to the GPU. There's a mesh class for loading 3D objects. It currently only supports objects and MD5 files. There's also a frame buffer and shaders, where you can have multiple frame buffers at the same time and create your own shaders with OpenGL or GSEL, OpenGL shader language. There's some helper classes for 3D where they give you a perspective camera, so you don't have to do all the math to do the transformations and stuff to have 3D. They have a decal batcher, which is pretty similar to the sprite batcher, where you can do the rendering of all the decals in the batch. They have the model loaders for loading the meshes, which is just the object files and MD5s. And then they have a basic renderer where you can give it materials and lighting, and it can do some really simple lighting calculations. As mentioned before, LibGDX also has built-in physics. It has both 2D and 3D physics library. For 2D, it uses Box2D, which is a very popular 2D or physics engine for 2D games. It's used in almost any game that has physics, and it's on the phone, like Angry Birds. For 3D, it uses the Bullet Physics library, which is another very popular library. NASA uses it for their rendering and for their Mars rover to do calculations. Both are implemented through the Java native interface, where they're done in C, C++, so they have the efficiency that they need for the physics calculations, but it can be accessed through all the Java library. There's also some helper classes within the physics realm. There's a bounding shape, so you can do collision detection easily, and volumes. There's frustum culling, so you can do picking and culling out objects, and there's an intersection and overlap classes, so you don't have to do all the manual. This is going on. I'll just turn this off. Intersection and overlap testing, so you don't have to do all the manual testing, and it can do it through the most efficient algorithms that are out there. Lastly, there's the audio and file system and input. For audio, you can play streaming music or just sound effects. It currently only supports WAV, MP3, and OGG files. And you can get direct access to the audio device to record audio and do a PCM playback. As mentioned before, the input is all abstracted, so mouse and touch input are combined into the same events. There's gesture detection and keyboard access, along with accelerometer and compass. And the file system is all the same throughout all the platforms, just one access. But there is a read-only emulation for the JavaScript, so you can't really have the security issue with JavaScript when you're running through the library. And there's also a lightweight preference system that you can store simple key value pairs like level or how much money you have, and it's very quick in access. Lastly, there's some utility tools that aren't really part of the library, but they come along with it. It ships itself with a 2D and 3D particle editor, so you can use a fancy tool to create particles very easily, export them and import them in the library, and they can be used almost instantly. There's really no setup you need to do. There's a texture packer, so you can create texture atlases / write sheets really easily. And there's a bitmap font generator to generate all the fonts you want to use, so you don't have to use TrueType fonts. And that's my presentation. Any questions? Yeah, it does. Almost all the objects are managed by LibGDX itself. So, like, if the app navigates away to the home screen or something, if for some reason loses the OpenGL context, if you did it in a native application, you would have to handle that yourself. But LibGDX actually handles all of itself. So normally you would lose your context. You have to create all your sprites, do all that stuff, but it's all handled magically behind the scenes with LibGDX.
Do you have access to the underlying library? So if it's not requested by LibGDX, do you have the ability to go to the ANI and get the native library?
You can. I believe you can, but I haven't looked into that. I don't know a scenario where that would be needed, though. References. So for the next part, I was just going to do a live demonstration on how to use LibGDX. LibGDX also has a nice little project setup, so you can create your game or your project structure from a GUI. I'll just leave everything to default except for the SDK. If you can also choose your IDE you want to use. I'm going to use IntelliJ. You could also use Eclipse or just have a general Gradle setup. Yes, yes. That sun is right in my eyes. Yeah. I've tested it on, well, I don't have an Android device with me, but I've done it on an Android before. On this computer, I've done it on the Android simulator, the iOS simulator, the desktop, and the web. The only one I had any issue with was the iOS one, but that's because it takes forever for it to compile from Java to the bytecode to the Objective-C bytecode. No. They all look pretty much the same. When it gets built to the iOS, it built it as a native iOS application, so it doesn't look funky at all, even on iOS. It has a lot of support libraries in it. I think I think it supports all the way back to Android 2.0, or might be 2.2. So, but it's from there on, everything should be the same. So I'm just importing the Gradle project into IntelliJ. Here I'm just going to make it so I can run the desktop application. For some reason it doesn't auto-generate it. Just got to choose the desktop launcher, set the working directory. The working directory, all of it, unless you don't have an Android application, is always in the Android assets application, so it makes it easier for it to get compiled to the Android app. So if there wasn't an Android, there would be an asset directory inside of desktop or inside of core. So it's just to help load all the assets you need. So with that, you can run a simple app that they start you with, which isn't much. Right. Whoops. Messed up. Oh, I didn't. There it goes. So this is just the basic app I give you that has just this image and it loads it. For the demo app I'm going to show you how to use LibGDX with. It's going to be like a cookie clicker game where there's going to be something you just click, it spawns stuff, and it will just fly around. It's going to be like a coin box, and coins are going to fall out and have some physics. So for the application, I'm going to change the desktop application so the width and height of the window is more like a phone screen. I'm just going to set the width to... Oh. If I hit D, that pops up. Yeah, because I can't type D.
Copy paste from somewhere else.
Uh, sure, if I can. There it is. It didn't update?
That's for presentation.
Hmm?
That's for presentation.
Oh. That's better. Sorry about that. So now if I run the application, it should just be a bigger, more phone-like screen. I prepared some assets for this beforehand as a texture atlas. Mm-hmm. If you use like an IDE that goes on both of them, like IntelliJ or Eclipse, which are both cross-platform, it should be the same except for maybe the relative paths. Oops. So this is the inside the core inside the core module. This is where all the game code will be. So we have an application listener here, which is just a simple abstract class that implements all the basic methods you need to call for the rendering of the game. I'm going to have a texture atlas to load my textures, a sprite for a background. Oops. Background. can't type D. G. Coin box, sprite for the coin, sprite for the grass. Inside the crate, that gets called once the game initializes. This is where we can do all our initialization. We can get atlas to equal new texture atlas. Pass in the atlas file that's inside the asset directory. So I have it as called game.atlas. From this texture atlas, we can create all our sprites. So we can do like a background equals atlas.create sprite. Oh, this is gonna be a problem. How am I gonna? You can just copy it from here. Coin box atlas create sprite coin box. I use the texture packager that LibGDX has actually in my pre-made game I did before to make sure I knew what I was doing. Inside the desktop launcher, I have the texture packager. I create settings for the texture packager. I set the max height to be for an image to be 2048, and then I just tell it use these settings. This is where my images are. This is where I want to put them. This is the name of what I want it. And so you can put all your images into that image directory and not worry about it. Then every time you launch the desktop application or create the atlas, so like if you have someone who wants to do art and they don't know how to do the packaging, they can just put everything in there and it'll just be automatically done. So that's how I created this beforehand. Is it called grass? So with that, we can actually draw some sprites. We can do the BG draw. So inside the render method, LibGDX uses the OpenGL call, so it just clears the screen, clears the bit buffer, sets the clear color to be red, clears the bit clears the whole screen. Then the sprite batcher starts and ends, so we can draw all our stuff inside of it. So we'll draw the background with the batch. We'll draw the grass and the coin box. That's getting annoying. You need to set the coin box position to be the center. I'm going to set the coin box's position to be the center of the screen. To do that, you can do libGDX. You can do GDX has a static methods where you can go to like gdx.graphics input audio and do specific things in each one. I'm going to get the graphics object and get the width of it divided by 2 minus the coin. It's just a sprite. So it holds the image that was created from the texture atlas and has all the information about how to draw. Oh yeah, you can. I'm just, I mean, well, yeah. What do you mean by set position, pixel position?
Like when I'm working in Android, do a fraction of the screen size, get a position on that, or you can specify.
Oh, this is all in pixel relative. So it's just to get width and height is just the actual screen size. I could do an orthographic camera and do everything there, so the screen size doesn't matter, it'll always be whatever the camera is, and that way you would have no discrepancy between screen sizes and stuff. But I'm not going to do that right now. Alright, so if we run this, it should have some pretty images. Woo! So we just have some images that don't do anything right now. What we want to do is when we click the coin box, some coins spawn. Oh, I guess I should load the coin also. To do that, we need to make a way to handle events. There's LibGDX uses event listeners. So in the GDX thing input, you can set the input processor. New input. IH. And we're going to create a input handler. IH input adapter. So what we're going to do is when there's a touch event or a click, when it's let go of the screen, we're going to check to see if it's inside the coin box. If it's inside the coin box, spawn a coin. So the input adapter has a bunch of methods for all the types of inputs you can do. There's key down, key up, key typed, touch down, up, drag, mouse moved, and scrolled. So we only need to extend the on touch up. So we can do if coin box get its get bounding rectangle dot contains a point, and this point is going to be the position of the input. X dot input dot get x. Because that's relative to, I forget what it's relative to. I think it's relative, it's specific to the screen and is not where you think it is. This is always going to be the same spot if you do it this way. Yeah. I think that's the actual position on the screen, not like inside your camera. So inside your, when you have a input, you have the actual screen position on the screen, and then you have the the virtual screen coordinates, and the input gets the virtual ones, which is what we need here. So if we have a coin, we're going to do spawn coin, create a method. Can't type void. I can't type D and it pops up. So if I ever hit D, I have to judge the IntelliSense. So instead of spawning a coin right now, I'm going to load a sound and play a sound whenever we click the. I can call a sound. Let me. I just can't type it. So sound equal GDX.
Can't type GDX.
I can't. So from the audio context of GDX, you can create a new sound or music, and it takes in a file. To access the file system of GDX, you have to go through gdx.files.internal. This will be inside the asset directory, whatever the Android asset directory. So my file was just called, I think it was just called coin.wave, yes. Yes. So you don't have to worry about anything. You can have your own file structure and it'll all work. So inside the spawn coin, we're just going to do sound.play. So if we click the sound or click the box, it should play a sound. Except we don't have audio here, do we? this doesn't have audio, so. Yep. This is the game. If we had audio, it would make a noise when I click this.
Hang on, man. Fix it.
Well, I can also do.
Right now. Your mic isn't on, but that should be on.
That's actually really loud, but it makes a noise. So, what was your question? Yeah, the sound file was just to find a sound, then you load the sound through the audio context of GDX, and all that is, it just requires the file. And inside the sound thing, you can change a bunch of stuff, like you can set the pitch, you can loop it, set pitch, pan, change a bunch of little settings on it. So with that, we can try to creating coins to spawn out, but for coins to spawn out and fall around, we have to have some physics. This presentation really isn't about physics, so I'm just going to copy the code, or some of the code I did beforehand, but for physics on a 2D, we need box 2D, so we have a box 2D has a world. I never realized how much I used the D key.
Is there really no preference on that?
I so box 2D dot sorry, I'm not. If you want me to explain box 2D, I can. It's just a whole nother subject on its own. True. Where is it? Just going to copy the code that actually does the physics creation of the coin and the walls so it can bounce around. And then I need some stuff up here. Oops. What is it yelling at me? Oh, coins. So they have a bunch of coins. LibGDX also has a bunch of utility methods for like arrays and stuff, since Java has lots of garbage collection, and the garbage collector can go through at any time and slow down your whole game, and that's not good for a game because it needs to be performance intensive. So libgdx uses the Java native interface again to create arrays and hash maps and any other utility method that you would could think of in C, C++, so you don't have the garbage collector to run, and it controls the memory management itself then. But it does mean that it won't be more memory efficient, because if something is dead in it, it'll stay dead in it until the application is gone. So I'm going to use the array for the pop up. Oops. What this does, body point. I didn't even hit the D key, I hit S. Sorry.
That's a bad key.
No, because I've been using S a lot. Sorry. All right, so I have a bunch of coins being populated when I click the thing, or click the coin box. They have physics bodies attached to them so they can have interactions with the world. And now I just need to draw them. So I'm going through the array of coins, getting the position, setting it, set the rotation, and then draw it. So if we play this, I forgot to set the world update. I have a bunch of games open. All right, so coins fly out and have really annoying noise. When I was testing the sound, I accidentally put it so it plays it every time it renders, so it's playing it 60 times a second. That made me throw my headphones off. So we got coins flying around, but they don't hit anything. So we need to create some walls. I can just copy this. Just going to create a wall for the everything around the screen, so they can just bounce around. Oops. So we run this, the coin should bounce around, and we have a very simple game. And all I have for the demo, unless you want something more specific, but this depends on your system. Do you want to hear that coin noise a million times?
I like the coin noise.
It's the sound of money.
I am programmed to think that that's a good sound like too much Mario.
I guess the other thing I can show is showing it run on other systems, so I can compile it for Android.
I actually have debug code name on my phone if you're set up to push
I would have to set your phone up on my SDK and all that. I have the simulator up.
Came up on my offer. Imagine the software that you could push to the spot.
It has to be connected though. Oh, I have a backdoor on my app.
Yeah, maybe I should be volunteer. That's my phone though. It's a nice spot. That's why I suggested it.
That's why I picked it. Yeah.
Yeah, so I didn't pick anything.
While this is booting, I'm curious, are there any well-known games that have been developed using this framework?
Five Nights at Freddy's, the scary game that's, I guess, scary if you consider it. That's like one of the most popular because he's made like $1 million off of it or something. Google actually uses it for their game called Ingress. It's like a virtual augmented game that has fancy 3D things. Those are the two known ones I know off the top of my head, but there's a lot, people use it all the time for just little games on the App Store.
Does the author of this framework make money off of it in any way?
He's written books on it, so if you count that, I don't know if there's any actual monetary he's made from just having it. But here it's on the simulator, and it goes on. I can do it on iOS also. On the why is the
Are there any other things that you've made with it that you can show?
not on this computer. Let's copy this. I don't have like a full-fledged game. I like doing lots of little simple things like this. I have a more full version of this, but I did it on iOS with Swift. That was just because I wanted to try to learn Swift. There it is. Here's the iOS simulator. I want to say like 5 years. Yeah, the community's pretty big. They have their own forums. They have lots of stuff happening on GitHub also. The whole project's hosted on GitHub. Yeah, so this is the iOS. My computer is dying now. Looks the same. Oh, I think it's because this is the 6 Plus, or no 6. So I don't have the camera set up to change the resolution based on the screen size. And I guess the last thing I can show is the JavaScript version of all this. Oh, I need it. Yeah.
How far do you get the mobile client?
Didn't I ask you about the mobile version of GDX? So we can have like a pseudo-responsive web UI. It's not. Is it pseudo? I've tried it.
It's just compiling it to the JavaScript. Oh.
It's a presentation. Really all
Compiling together. It cross compiles it. For like the iOS, it compiles it to the Java bytecode, and then there's a Robo VM or something where it converts the Java bytecode to whatever Objective-C it uses. Yeah, so like the initial compile for like iOS takes a long time. But after the first compile, it all works pretty fast for the web browser. I don't know why it does exactly, but yeah, that does incremental builds. And this is the JavaScript version. It all works. It's,
So this is compiled here.
I think they use Flash for like sounds or something. I'm not 100% sure. Like if I go to well, this is all JavaScript in here, I think. I haven't actually looked into it, or I guess I'm gonna look here. Yeah, it uses. You don't like Google Web Toolkit? Yeah, that's the only thing it uses to get it to run on JavaScript. But that's all the platforms shown. So any more questions? It actually runs on all the browsers, even Internet Explorer. I forget what they use to make it work with Internet Explorer, but it does. It does? Okay. But yeah, that's the end of my presentation. I can post a link. I don't have one right now, though. I can do, the slides just have like LibGDX stuff, not my actual code. I can push it to GitHub and post it on, I can post my slides and the code to GitHub or something.